All right, hello everyone, and welcome back. In today's video, we're going to go ahead and introduce functions in C++. So here's our goals for today. By the end of this video, you should be able to explain this idea of top-down design and procedural abstraction. And basically, these are ways of saying how we can simplify programming using functions. We'll also briefly talk about static cast and how we can use static cast to read variables of one type as another type. And finally, we'll spend the majority of the time focusing on how we can code and implement functions and programs. We'll learn how to declare, define, and call functions using C++. Let's start out with some review from last time. So go ahead and try this question. And if you want, pause the video and see if you can identify the correct answer. All right, so if we take a look at this program we're given, you see we have a main function and a for loop. And so we're saying starting at n equals 0, as long as n is less than or equal to 10, we're going to output the value of n and then increment n. All right, so you can see we're starting at n equals 0. So first, this for loop is going to say, okay, well, 0 is less than or equal to 10. I'm going to output that number 0. Then n gets incremented to 1. We repeat. So you'll notice this loop is going to go through and output all the numbers. And notice what happens with number 9. Output 9, then n is incremented by 1, so 9 plus 1 is 10. But since we are using the Boolean n is less than or equal to 10, we will run the loop one more time with number 10. So output 10 to the screen, increment 10 to 11. Once n becomes 11, our loop will stop. So in this case, our output will be starting with n equals 0 and ending with n equals 10. So correct answer is choice E. So a little bit more review from last time. So in our previous video, we covered strategies for designing and debugging loops. And so we covered common mistakes that are often made when using loops. So that included counting errors, variable scope, incorrect semicolon placement, off by one errors, and infinite loops. So be careful of these errors. Make sure that you control your loop properly, and you're very mindful of where your loop is starting and stopping. So watch out for those errors. Make sure your booleans work as expected. Be sure to declare your variables in the correct place. And check those upper and lower bounds of your loop. If you'd like some further review of loops and files, I would encourage you to check out our previous videos for more examples. So let's go ahead and continue on with functions. And you might remember the very first program that we wrote. We talked about the Hello World program and how we used this syntax int main. And remember, when we use int main here, essentially what we are doing is we are creating our main function. And in our very first video, I said, well, don't worry about what a function is right now. We'll cover that later. Well, it's now later, so let's go ahead and understand more about why we use this syntax. We have already been using these main functions in C++, but by the end of today's video, you should have a much better understanding of how these functions work and how we can write additional functions in our programs. So first, let's remind ourselves of what functions actually are. And in math class, you may remember learning about functions as well. Suppose you have a math function from math class. You may have used the notation f of x equals x plus 3. So f of x is how we would write a function in math class. And you might remember that if you input some value x, the output f of x is always going to be that input value plus 3. So for example, if I said f of 1, then 1 plus 3 equals 4. Also in math class, you might have used functions with two variables. Maybe you had f of x and y is equal to x plus y. And so there, if x is 1 and y is 2, f of xy would be 3. So the good news is, in C++, functions behave fairly similar to what you learned in math class. So let's now explain what is special about functions in C++. Now, the official definition of a function is that a function is a collection of statements, again in C++, function is a collection of statements which perform a task. So, for example, you might have some function called add together, and maybe add together takes two numbers. Maybe you have int num1. So here, add together would be the name of your function. And often we like to give our functions very descriptive names. So the function add together would be a function that adds its arguments. When we say argument, that is an input to our function. So suppose we did add together 1, 2. So here, 1 and 2 are the arguments. So essentially 1 is being plugged in for num1, 2 is being plugged in for num2. Add together will add those things together. And we're going to see over the course of this class that functions make our life easier. And it makes programs a lot easier to write and debug. Think about a program where you needed to add many numbers together. Rather than writing the code to add two numbers over and over and over again, you could write add together as a single function, and then every time you wanted to add your numbers, you just use the add together function. So functions also help your programming by making fewer lines of code to debug. So ideally, every time you need to repeat a task, you would just use the function that you have already written. Also, functions improve maintainability of programs. Suppose you wanted to change the way you are doing your addition. Rather than having to go through your program and update the code every single time you perform addition, you would only need to tweak the add together function. And changes made inside the add together function would be effective anywhere add together is used. And we'll also learn later that you can also build your programs one function at a time. And we'll see that another really good programming strategy is to test and debug functions one at a time, and then combine them all together in your finished program. that can greatly simplify the amount of debugging and the amount of struggling you might do with a more complex program. Let's look at a few more definitions. There's this term called top-down design, also known as stepwise refinement. And these are basically a fancy way of saying breaking our algorithm down into smaller and smaller tasks. And so the idea is to take a complex process and break it down until the tasks are so small that they can be done by individual statements. Another term is modular programming. In modular programming, the idea is instead of just having a whole bunch of steps, you break your program down into manageable functions or manageable pieces. And you can write these individual functions on their own and then combine them together in order to produce your finished program. So modular programming can be really handy if you're writing a very complex program because you can test and debug functions one at a time. And then once you have tested and verified the functions work, then you can combine them together in the finished program. So modular programming can be really powerful, but it also requires a bit of planning. You want to make sure you have a very nice algorithm and a plan for those functions so that you can put them all together at the very end. So why do we bother with this stuff? Here's two examples of some programs that you might be writing. So up to this point in the class, we have been primarily writing most of our code inside the main function. And it turns out that that's not how programmers actually write their programs. Here we're just learning and we're practicing skills. So sometimes it's convenient to just quickly practice or demonstrate something in the main function. If you were to go out into industry and look at other people's programs used in real life, you would find that the main function is usually fairly short. And that's because the main function will actually call other functions. So it will actually call other functions to perform tasks. So rather than having every single step of your program inside one main function, you instead have a main function that sort of says, okay, do this function, then do this, then do this. The main function is delegating out the tasks of the program to separate other functions. So this is more of that modular programming approach that we mentioned earlier. And so a big advantage of this is first, it can make programs easier to understand because these functions might have descriptive names. Each one does a certain task. Also, the programs are much easier to edit because notice every time that we need to change the task function one does, we would only need to modify code in one spot. We wouldn't need to go through our main function and change every statement that did that task. Also, overall, there would be less code to write because anytime we need to repeat the tasks of a given function, we don't have to rewrite all the function's code. Instead, we just use the function. Also, as we mentioned, easier to test and debug because we can actually write and test each function one at a time if we choose. Another big point, remember in industry or in the real world, you're probably going to be working with a team. And so if you've got a big complex program with many, many functions, it's a lot easier for the teams to divide and conquer if everybody agrees on what the functions are supposed to do. Then you divvy up the functions and everybody starts coding. Then it's a lot easier to combine everyone's work back together at the end and finish the program. So functions can greatly simplify the programming process. So as your programs become more complex, you may find that you rely more and more on functions in order to more easily write, test, and debug your programs. So let's first start by looking at what's called a predefined function. So you may remember that C++ actually comes with some functions that are already predefined. We call these libraries. So we already do have some functions that are available for us to use. As long as we use the correct include headers, then we can use these predefined functions. So one example is the square root function. So this is just like the square root in math class. So here we have, for example, answer equals square root of 9. So that's the same thing as writing in math terms square root. So in this case, square root of 9.0 will return the value 3 because square root of 9 is 3, and actually it returns it as a double. And so if I write the code answer equals square root 9.0, square root 9.0 is going to evaluate to 3.0, and so value 3.0 will be assigned to answer. So in order to use the square root function, we need to include the CMath header. And one thing to note is that some of these headers, including CMath, they will also require the standard namespace in your C++ headers. So good idea to remember to use using namespace standard and the appropriate include headers. So here's a list of some other predefined functions that are available in C++. So there's our square root function. We also have power, so that is for exponents. And we'll mention in just a moment, but in C++ we can't use this exponent operator. At least it doesn't work for exponents. So that's why we have this power function. So for example here, if I say POW 4.0, 3.0, that will take 4.0 and raise it to the third power. So 4 times 4 times 4 would give us 64. So notice these functions do require that the input argument be of double type. Also have ceiling and floor, so these would round for us. And then we also have absolute value functions, both for ints and doubles. So for the purpose of this class, I don't expect you to memorize every single predefined function that exists. But if I were to ask you to write a program that requires them, I would expect that you know where to find these functions and understand how to use them. Once again, just another reminder about the power function. In some of the programs that we'll write, we might need to take the square of a number or calculate an exponent. And so you want to be careful here because the exponent operator is actually a special symbol in C++ that does other stuff. So if you want to calculate a exponent, you need to use the power function. And again, that requires the CMath header. I'd also like to share another predefined function that is occasionally useful for certain types of math and engineering problems. And this is called a pseudo random number generator. Here we say pseudo because the number is not truly randomly generated. It actually will have kind of a distribution associated with it. But if you need to do some calculation that requires a random number, this pseudo random number generator will work pretty well. And so again, I do not expect you to know how to do this for the purposes of this class. But if you ever need to write a program that uses random numbers, or maybe you need to test a program with random numbers, sometimes it's a good idea to know how to create random numbers. So in this case, if we want to use the random number generator, we need to include a few special headers. So C standard library and C time. And this time function will actually return the number of seconds since January 1st, 1970. So we use that kind of random number to seed our random number generator. And then we can use this function rand in order to return a random integer that is greater than 0 and less than rand max. So let's look at a couple quick examples of this. And so once again, you can use the modulus operator and addition to kind of tweak the random number range that you want. So if you have random number modulo some value, that will give you the random number between 0 and n minus 1. For example, suppose you were making a program that you wanted to simulate rolling a 6-sided die. So in this case, we could declare an int variable named die, which would be like rolling a 6-sided die. So we need to return a random number between 1 and 6. So if we want to do that, we could say rand ampersand 6 plus 1. So this would give us a random number between 0 to 5. And then we have to add 1 to that. And so this will actually give us that random number. Similarly, if we wanted to get a random number between 0 and 100, maybe we were making a number guessing game, then we could say rand ampersand 101. So once again, I'm providing this information to you more for your own reference in case you ever do need to write programs that use random numbers. These can be very useful for debugging, but just know that these functions exist in case you need them in the future. Okay, so that's it for the predefined functions. But of course, most of the time for us as programmers, we need to actually be able to create our own functions. And so that brings us to how we write functions in C++. And I've broken it down into 3 easy steps. When you use functions in C++, you typically need to do these 3 main things. Make sure you remember each of these steps each time you want to use functions. First step is to declare the function. This is just like declaring a variable. You want to let the compiler know that the function exists. So what we do is we use what's called a function declaration. We let the compiler know that our function exists. And the other thing the declaration does is it also gives a compiler a heads up that it should link that function's name to a definition later in our program. Some textbooks call the function declaration the function prototype. So if you see the word prototype, that is the same thing as a function declaration. Next step is to define the function. So we actually, inside the function definition, that is where we write the code which the function should execute. So this is where you actually say, okay, if I have that add together function, inside my function definition, I write the code that will allow that function to complete its task. And then finally, after we have declared and defined our function, then we will be able to call the function. And when we call the function, what that means is that we cause the function to execute. So one thing to be very careful of here is that we need to make sure we need to declare the function first. All right, so once you have declared the function and defined it, once the function has been declared and defined, it can be called at any point after the declaration. The declaration helps link that function's name with the actual definition that the function should perform. So now let's take a closer look at each of these 3 steps, and we'll explain how do we actually code up the declaration, definition, and call for a function. So first is our function declaration. And you can see we have an example here for a add together function. So a declaration should include the code shown here. Once again, as we mentioned, a function declaration is very similar to declaring a variable. And so we tell the compiler about our function, and as we mentioned before, this allows our function to be called before the function definition appears. So we could have the function definition listed at the end of our program after our main function, but we'd still be able to use our function at any point after the declaration. So let's take a closer look at the stuff inside this declaration. First thing we see is what's called the return type. So that basically tells us what type of data will the function calculate and send back when it's finished. So in this case, the add together function, it's going to take my first number and second number, which are in the argument, it's going to calculate the sum, and it's going to return the sum of first number and second number as a double type variable or a double type value. So return type is very important. We want to make sure we know what type of data that function is going to give us after it has run. So let's return type. Next is our function name. Remember what we said about self-commenting code? It's a very good practice to use descriptive names for your functions. So you should not be calling your functions function 1, function 2, function 3. That is not descriptive. However, if you name your adding function add together, it's very clear what that function is trying to do. Another thing to notice is that some programmers capitalize the first letter of a function's name. And so this is to avoid confusion with regular variable names or other lowercase names in the program. I personally will accept either case, but I do want you to make sure you use descriptive names when you are writing your functions. So once again, function name, that is the name we give to our function. Next item is the arguments and the data types of the arguments. So we can see that in this case, our add together function will accept 2 doubles as its input arguments. And we see that the function is expecting both inputs to be double type values. So this gives us how many and the type of the input arguments. So these names, first number and second number, they also have kind of a fancy term that we call them in C++. We sometimes call the name first number and second number a formal parameter. And basically what this is this is a placeholder for the actual arguments. So if I were to use this function in my program, I might put some value inside these variables. Like suppose I put the number 1 inside first number, number 2 inside second number. So the actual data being added are the things I store in these variables. I plug in arguments to these placeholder values. So formal parameters are basically placeholder variables, and once we call the function, we input our actual argument into those variables. So you'll also notice one more thing about this function declaration. Notice these comments. I'd have comments in my function declaration. And so this is a very important practice, and this is something that I actually require that you do in every assignment. So for this class, when you write a function declaration, you must include comments explaining the precondition and postcondition. This explains what the function is actually doing. So the precondition tells us the required initial conditions needed for the function to run. So in this case, we need first number and second number to be initialized to some value. We can't add our first number and second number if they do not contain any data. Next is the post condition. The post condition tells us what happens. Basically, it tells us the result after the function has executed. So here we are told that add together returns the sum of first number and second number. Notice the post condition does not say how the sum is calculated. Does not say how the result is calculated. Instead, it just says what the result will be after the function runs. So notice we're not going to be necessarily going into tons of detail here. You just want to give your programmer or yourself the information you need to understand what this function does. So this is a very important practice. Always make sure you include precondition and postcondition comments with your function declaration. So make sure you always include the precondition, postcondition. It will be an easy way to earn points on assignments in this class. You'll see often part of your grade is that you've written those precondition, postconditions. Remember, precondition, you tell the initial conditions that are required for that function to run. Postcondition tells us the result after the function has executed. It does not say how the result is calculated, but it tells us what that result will be. Couple other things to note about the declaration of your functions. So in our class, we follow the practice where function declarations are placed near the top of the program before your main function. Well, why would we do that? That is so that the function is declared at all points, or basically, so that the function is declared and available after. Right? Because we want to make sure that our functions are available to be used at any point after the declaration. So we want our function to be declared and ready to go before our main function even starts. That way, our functions are ready to go and ready to use in main. Also, remember you must include precondition and postcondition comments underneath each function declaration. And remember, you need to include either the declaration or a full function definition before any call to function, otherwise your program won't compile. The program will give you some error like undefined reference, or it will show the function in red because it won't know what that function is. Let's go ahead and practice with an example. So suppose we have this function declaration. The question is, what data type does this function return? If you were thinking int, you would be correct. Since the return type is listed as an int, that means the function will return an int value. Now let's move on to function definitions. Here's an example of a function definition. And so here we have the function add together. And you'll notice once again, this whole part here is containing the similar information. In fact, the exact same information. This contains the same information as the declaration. In fact, the name and the arguments need to match. So notice, since this is our definition for the add together function, we need to match what we had in our declaration. So you'll notice the return type, the name, and the arguments all match. The difference is, in the declaration we have a semicolon. Notice in the definition, there is no semicolon after that parenthesis. So the first bit of our function definition is the header, and this header part contains same information as declaration, so it must match. Then we have curly braces. And then inside the curly braces, we put the statements the function should run, or statements functions should execute inside the curly braces. And notice, remember to indent. Inside the braces. So in this case, this add together function is actually very quick to write. So we can actually write the function's statement using a single line of code. Since we are just adding first number and second number together, all this function needs to do is return first number plus second number. But had I wanted, I could have actually written the function a little bit longer. I could have also said something like double sum equals first number plus second number. And then I could have said return sum. So notice that you do not have to have all the code inside the return statement. In fact, most of the time, you're probably going to need code before the return statement. So not all the code needs to fit inside the return statement. Sometimes if you have a very short function, you might be able to fit everything in the return statement, but you certainly don't have to. This other approach would have also been acceptable. So once again, function definition, it describes how the function does its tasks. And when we call the function add together, it's going to execute the code inside the curly braces. So anything inside those curly braces will be executed. And so the function definition can appear before or after the function is called. So one thing to note, if the definition appears after the function call, the function must be defined first. And in our class, we follow the convention that for now we are going to put all the function definitions after the main function. So we put our declaration first, we have our main function, then we put function definitions after. And remember, notice there is no semicolon after the parentheses in the function definition. Let's go ahead and try another practice question. So here we have our add together function. And suppose that we have these values. First number is 7, second number is 2.5. And suppose we had used first number as 7, second number as 2.5. And suppose we went ahead and we plugged 7 and 2.5 into this function. And so we have int add together, and we're returning first number plus second number. Question is, what value would add together return when it executes? Take a moment and think about it. So if you look at our function body, we would see that we're basically going to return our first number, which is 7, plus second number, which is 2.5. So basically, we're going to return 9.5, right? But wait a minute. Return type is an int. What happens if we try to store the value 9.5 in an int? We're going to lose the decimals, right? This is going to create that truncation error. So in fact, the value that is returned is 9. And this happens because our answer was 9.5, but because the return type is int, because that return type is int, any decimals that are calculated in that function are going to be lost. Remember, no rounding occurs. We are just going to lose that 0.5 and we're left with 9. So very important that you pay attention to return types to make sure that you don't accidentally lose data. Let's go ahead and move on to function calls. So calling a function is actually very simple. We use the function's name followed by parentheses. So to call add together, we write add together, and then we put parentheses, and inside the parentheses, we put the arguments that the function expects. So in this case, add together is expecting 2 arguments, a first number and a second number. So for example, I could have 1.0, and I could have 2.0. And when I call that function add together, it will plug in the 1.0 is plugged in for first num, or in this case for first number in the definition, and then the 2.0 is plugged in for second number. So we actually exit our main function and we would go back in to our function definition. We'd plug in 1.0, 2.0, and we would perform 1.0 plus 2.0, and we'd return 3.0 in this case, if the definition from earlier was used. So there's a couple other things to note about calling a function. If I return a value, so in this case add together, it should return a double, or it will return the sum. We need to make sure we give add together a place to store that sum. So in this case, add together is going to return a sum, but you want to make sure that you give the function a place to return the variable 2, or to return the output value 2. So for example, in this case, I could say double sum is add together, and then the sum would be, we could store the sum in a variable, or you could also have it inside a cout statement, like cout. So here you would output it. So if you were simply to call the function add together, but not give it a place to put the result, then add together would execute, but the sum would disappear immediately. So if we want to use the sum elsewhere in our program, we would need to take that result and store it in another variable, or we would need to output it in a cout statement. So here, for example, if I said cout the sum is add together 1, 2, this would output the sum is 3. So function calls can be used as part of cout statements. We can store the value that we calculate into a variable, or we can just call the function on its own. Once again, if your function is outputting a value, make sure you give that function a place to return the value to, otherwise the value will be lost. It's as if you were throwing the sum and no one was there to catch it. So you want to make sure you give that function a place to give the output. Okay, so let's go ahead and see this entire process in action. Here's an example of using the function add together in a full C++ program. So notice what happens. We have our include headers, and notice our function declaration is at the beginning of the program before the main function. This ensures that our functions will be available at any point after that declaration. Notice the function definition is listed after the main function ends. And then inside our actual program, we can call add together inside the main function. Basically, we can call add together inside main or at any point after the declaration. So in this case, notice we ask our user for a first number and a second number, and then input 1 gets plugged in for the first value, input 2 gets plugged in for the second argument, and this program will output the sum of our two numbers to this screen. So let's take a closer look at what actually happens when we call add together. And so this is what actually happens. Suppose I have run my program and I have gotten to this point where I want to call add together. Turns out that when this function call is read, we exit the main function or the current function that we're in. Here it happens to be main. And we go to the function's definition. So here, since we've called add together, we're going to exit the main function. We're going to go over to where add together's definition is. And we're going to put input 1 as our first number. So we take the value stored in input 1, so we copy the value from input 1 and put it inside first number. So anywhere where first number appears, we plug in the value stored in input 1. For second number, we plug in the value stored in input 2. So then we run the code in add together. So here we go ahead, we run the code in the function, and then once we reach the return statement, after the return statement, we go back to the point where the function was called, so here we return first number plus second number. So here after the return statement, we go back to the point where the function was called, and if we're returning a value, we give the returned value. So in this case, if we plugged in, for example, 1 is input 1 and 2 is input 2, then add together 1, 2, that would give us the returned value of 3. So the sum of our numbers here, the value 3 would be returned. And in this case, since this is part of a cout statement, the value here is outputted as part of the cout statement. So it's a very interesting process here. Notice anytime our add together function is called, we would actually exit the current function and go to that definition, run the code, then return back to where we started. Let's take a moment and briefly demonstrate a few more things using CLion. All right, so here we are in CLion with our add together function. And so if we go ahead and run this, you can see exactly what happens. So if I enter my first number, 3, second number, 4, notice I get the sum of my numbers is 7. Just for fun, let's put in a breakpoint and run the debugger so you can see what's actually happening here. What I can also do is I can use this command called step2, and I can actually see what's going on in that function. So for example here, maybe I go ahead and enter my first and second numbers again. So once again, in my debugger, I've got my 2 values there. But when I want to take my sum, I can instead step into this line. And notice what happened when I went to step into. I stepped into this add together function. And now I am inside add together. You can see now that first number was assigned the value 3.5 because that was the value stored in input 1. Second number was stored as approximately 4.6 because that was the value I plugged in for second number. And so if I can step through, you see that I went ahead and I added the 2 arguments. And now if I go back, you're going to see that I'm going to add these 2 together and I'm going to return the sum 8.1. So in order to complete this program, I am actually exiting my main function, entering add together, plugging in my values for first number, second number, and completing the addition. I'd also like to briefly illustrate that point I mentioned earlier about making sure we give our function a place to return its values. Notice if I were to just call add together like this. If I just put the function call just like this, you'll see that the program's still going to compile and run. This will still run. Like I can give it my numbers, 3.5, 4.5, but notice if I call add together, it's going to calculate that the sum is 7, but it didn't have anywhere to store that sum, so I'm unable to see the result. So if I want to actually see the value that my function has returned, I need to actually give it a place to store that result. So notice here, I'm giving add together a place to put the value that it calculated. So it's able to return the value into result and then output that sum to the screen. And so here we see the sum is 8.1. If I were to run the debugger and track this, Notice I have input 1 and input 2, and if I step over, notice result is able to receive that sum, and then result is outputted to the screen. So be very careful here. Any function that returns something needs to have a place to return that value to. All right, so a couple more key terms to cover here. So the values that we pass into the function, or the things that we plug in, values we plug in, those are called arguments. So in this case, input 1 and input 2, these are my arguments because I am plugging input 1's value and input 2's value into add together. Right? So the value stored in input 1, that is going to be put in for first number, and value stored in second number is input 2's value. So these placeholder names, first number and second number, and we call these formal parameters. So first number and second number are placeholders. First number and second number are placeholder variables. And these are variables which receive the arguments. So if you see people talking about parameters, formal argument, those are the placeholder values that receive argument we plug in. A little bit more about calling functions. A main function can call any number of functions. And functions can call other functions. And functions can even call themselves. That's a special thing called recursion. You may learn about recursion in more advanced programming classes. Remember, before a function is called, the compiler must know the name, the return type, number of parameters, data type, and it also must know the definition of that function. So you want to make sure that you have declared and fully defined your function before you start trying to call it. Other things to know about functions. Functions can have no parameters, one parameter, or multiple parameters. So functions don't have to always take an argument. Some functions take no arguments, while other functions can take many arguments. And for now, we are using a procedure called pass by value or call by value, and that means the value stored in each argument is copied into that parameter. So the function uses copies of its input variables, its input arguments, rather than changing the actual value of an input argument. So functions can't go back and change the thing that was plugged into them. Instead, the functions use copies of the arguments. Another thing to note, we talked about scope. So when we talk about parameters, basically we can say that in this case, first number and second number, first number and second number They only exist inside the add together function because that is the area bounded by those curly braces. Since first number and second number are declared and used inside add together, they only exist inside add together and they disappear when add together stops or when add together has finished. And one other thing, as we mentioned before, arguments will be promoted or demoted as necessary to match the expected parameters. So if the function is expecting a double type argument or an int type argument, the inputs will be adjusted if you're trying to give your function an argument that is a different data type. Okay, so now let's talk a bit more about the return statement. So we've been using return already up to this point. And we've been using return 0 to end our main function. And so, as you might expect, the return statement is used to end execution of a function. And the return statement can actually be placed anywhere inside a function, but any statements that follow the return statement will not be executed. But it's also possible to have return statements or even multiple return statements in a function if you want to return error codes or if some error condition is met. So you could have a function add together, and then you could, inside your function, if you have an error condition, you could have some message, and then else, you return something else. So it's possible to have more than one return statement in a function, but once one of the return statements has triggered, then you are going to exit the function, and so any other code in that function will not execute. So the return statement will return that value that our function calculated, and it will return that function back either to main or to wherever place that function was called. So if our main function called the other function, then we return the value to main. If a different function called our function, we return our value to that different function. And you can return all kinds of things. So you can just return 0. You could return an expression, like hours worked times pay rate. You can also return nothing at all. So functions which are void type actually do not return any value. And so it's also very important to note when you are declaring and defining the function, you have to indicate the return type in the function declaration and definition. And if your function does not return any value, then you use void type. So if our function should not return a value, then you can create a void type function. And notice void functions, you don't have to have a return statement. In a void function, the function will end at that last closing brace. You don't need a return statement. Okay, so we've got just a couple more points to cover, and then we'll do some examples. So let's cover real quick this idea of call by value or pass by value. And so you'll notice that when we were doing our sample code earlier, we saw that whatever we put in input 1, that became our first argument. Whatever we put in input 2 was plugged in for our second argument. So this process of plugging in our arguments into the function is called call by value, also known as pass by value. Sometimes people even call it pass by copy. And so what this means is that we are actually plugging in copies of the values stored in input 1 and input 2. So here we're going to plug in copy of input 1, and here we plug in copy of input 2. So the value we put inside our add together function is not the original input. The original values of input 1 and input 2 are unchanged. So what that means is that even if our function changed the values inside the add together function, back in main, input 1 and input 2 are not changed. So let's summarize these things that you want to remember about call by value. So first thing to remember is that the values that we plug in to our function, those values are copies of the value stored in that variable. We're just using copies. The other thing to note is that the values are plugged in the order in which they are received. So if we give input 1 as the first item in add together, first item is plugged in for the first formal parameter, second value is plugged into the second parameter. So we plug our values in the order in which they're received in the function call. Another thing to note is that if you plug in a value for that formal parameter, like first number, that same value is plugged in everywhere those formal parameters appear within the function. And finally, the number of arguments in the function call must match the function declaration and definition. So in this case, if I want to use my add together function, I must give it 2 arguments when I'm calling it. If I really wanted, if I only had one thing, I could put input 1 twice, but in order for this function to call properly, and in order for the program to compile and run, we need to make sure we give our function call the expected number of arguments. So number of arguments must match. We must give all those arguments when we call our function. So it turns out you can also make functions that return any data type. So we can return string type, we can return bool type, char type, int type, double type. So any defined data type, we can have our function return. There are some exceptions like arrays that we'll cover later, but for the standard data types we know right now, like ints and doubles, chars, bools, we can return those types. So functions which return a bool or a true or a false, those functions are called predicates. And the neat thing about functions that return a bool is that that function can be used anywhere a bool statement is allowed. So we can use a bool function to also control loops, if-else statements, and other Boolean statements in our program. So a couple things to note about bool functions. Bool functions must return a true or a false, and we do need to declare the return type as a bool. And the function body must return true or false values as part of the function. Let's look at an example of a bool function. So here's a nice little function that leverages bool. So in this case, we have written this function definition called get yes no. And notice what this function does. It will basically take the message that we give it. So we could say, for example, want to play again. Right? We could give any sort of yes no question we can put inside prompt message. And then inside the bool function, we have a loop. And notice what we do is we output the prompt message. So here we're outputting want to play again with yes, no after. Then we take in the user's answer. And then notice if we get a yes, function returns true if the user answers yes. And then if our user answers no, the function returns false. And then if the user gives us something bad, then we keep nagging the user until they give us a yes or a no. So imagine if you were writing a program that required a lot of yes-no questions. You could write a function like get yes no, and then anytime you wanted to ask a yes-no question and nag the user for the right answer, you could just change the prompt message that you plug in, ask different yes-no questions. It's actually a very nice way of writing one function and being able to reuse it multiple times in a program. All right, we have one more topic that we should review related to functions, and that is called typecasting. In some of our earlier videos, when we covered data types, you'll remember we also talked about static cast. And so what we're doing when we use static cast is we are reading variables of one data type as another data type. So we are not changing the variable itself, but we're purely reading it as another type, sometimes to avoid errors or to assist with calculations. So you'll remember in this case, we can see that if we want to read total candy as a double, notice that we can actually use static cast double to read total candy as a double value, and that way, if we produce a decimal, then the result of our calculation would still preserve the decimal places. So we read total candy as a double to avoid truncation errors when dividing ints. Let's look at a quick example. What would be the output of the code shown here? So here we have 13 for total candy and 4 for number of people. So in this case, we have 13 here and 4 here. We are using static cast. So in this case, 13 divided by 4, that's actually going to give us 3.25 because total candy is read as a double. Had we forgotten to use static cast double, and had we just divided total candy by number of people, we would have only gotten 3 as our answer. All right, so real quick, let's go ahead and end this video with a short demo. So let's go ahead and see how we could update our code to add some more functions. And so here, we want to add some new functions to our add together program. We want to add a function called find smaller, which will return the lower of the two values. Should be parentheses. And then we also want to write another function called subtract smaller, which will return, in this case, this is typo in the post condition, this will subtract the smaller number from the larger number and return the difference. Between the smallest number and largest number. Okay, so here I have my original program, and notice I only have my add together function. So I need to add the declarations for the new functions. So we've got the declarations now. Next step is to write the definitions. So we need to add the definitions for our new functions at the end of our program after main. So once our main function has ended, we can add definitions. So notice when writing our definitions, we do not include a semicolon after that header, but we want to make sure that we have correctly typed the name and the information so that we match our declaration. Here we want to return the smaller of the two values. Since we need to compare the two values, we need to determine which value is smaller, return the smaller value. Otherwise, if the values are equal, let's just return first number. So what we can do is we can do something like this. If first number is greater than second number, so we return second number. If second number is greater than first number, then we return first number. So we're returning whichever one is smaller. If the numbers are equal, then neither of the two if statements will have triggered. And in that case, let's just go ahead and return first number. So that way we return first number if both values are equal. Okay, so find smaller is done. Now we can go ahead and write subtract smaller. We can use a similar approach as what we had before. We can say, for example, if first number is greater than second number. So in this case, first number is larger, so we subtract the smaller. If our first number is less than second number, then we return second number minus first number. So we're subtracting the smaller value. And then if the numbers are equal, so here we would return first number minus second number. The numbers are equal, so we just subtract like this. So we've now defined these two new functions. So now we can go ahead and call them in here. So let's add a little bit of code just to test these functions out. And so notice now we can call find smaller, and we can still use the same approach as we did before. So we can plug in input 1, input 2. The function requires 2 inputs. And notice if I do not give it a second input, then I get an error. So I want to make sure that I give my function the expected number of inputs. And then I could also say, for example, result. Here if I wanted to instead give my result to a cout statement. So here I can say the numbers are the difference apart. All right, so if I go ahead and run this, notice what we get. First, we enter our first number. So I'm going to say input 1, maybe 13.5. Enter my second number. Maybe my second number is 2.5. Notice I get sum of my numbers is 16. That's 13.5 plus 2.5. Correctly found my smaller number is 2.5. So I was able to correctly add in these functions in order to perform those extra calculations. All right, so with that, we'll go ahead and end our video for now. And so hopefully now you can see how functions really can simplify your programs. And as your programs become more complex, using functions is going to become more and more important. Also, make sure you remember how to use static cast to read variables of one type as another type. You'll see that if you put an int in a function that's expecting a double, the function may perform some of this casting automatically. So you want to be careful and pay attention to the data types you're using. One of the best ways to get better at writing functions is to write functions. So please take some time to practice these programs we've demonstrated and try writing some of your own. Thanks everyone for joining the fun, and we will see you in the next video.